everyone. In this video, I will write a function that is getMid. Means we are writing a function for getting the mid element. Okay, mid element of a singly linked list. There are various ways to do so, but I'm going to tell you a different method for doing this thing. Okay, let me first suppose this is our linked list 1 2 3 4 5. What will be these are the elements of our linked list. You can see I have simply written 1 2 3 4 5. Okay, and what will be the mid element? Consider each element as a node. 1 is a node, 2 is another node, 3 is another node, 4 is and so on. 5 is last node, 1 is first node. Okay, 3 will be the mid node. Okay, 3 will be the mid node, and you can see clearly on the left side of the 3 we have two nodes, we have two elements, and right side we have two elements. So on the visually you can see this 3 is our mid node. Okay, but what if I will increment the I will add push back an element. Okay, I have pushed back an element into the list, that is 6. Now total number of elements is 6. This is even. What will be the mid element now? Here mid element will be both 3 and 4. Means if we do n by 2 and in odd cases, if n is odd, means number of nodes and number of elements, number of nodes is odd, then n by 2th element will be the mid node. Okay, and in case of even, n by 2 and n by 2 plus 1 plus 1th, means here n is 6, we will divide 6 by 2, that will be 3, and 3 plus 1, that is 4. 3 and 4 both will be the mid node, but we will consider in the singly linked list we will consider only the greater one, means we will consider 4 as mid node. Okay, this is how this was a way we can simply think about the mid node. Okay, but I'm not going to do this. You can use this method to find the mid node or delete a mid node. You can do this. Okay, I'm going to tell you a better approach. You can say a smart approach. Okay, first we will start from here. We will take two pointers. Suppose we have C1, okay, and another pointer we will take C2. Now both pointed on the first node, both points first node. Here it will both have the address of first node. Okay, we will move C1 by 1 and C2, we will increment C1 by 1 node, and we will move C2 by 2 node. Okay, and when C1 will be on last node, C1 will be on mid node. Okay, let me show you how we advance a node, how we increment a node, how we move from one node to another node. We will move from one node to another by next element, by next pointer. Okay, we can see we will write C1 to next. Okay, and I will write C2 to next. Okay, this is how sorry, C2 to next to next. I'm incrementing both C1 by one node and C2 by two nodes. We are moving from one. Let me show you. Here first C1 on the node 1. Okay, I'm just writing simply to understand. Okay, first C1 and C2 both points this node, first node. Okay, that has the address of first node, that is 1. Now C1 will move to one node. Okay, C1 will be on second node, that will be 2, sorry 2, and C2 will be on C2 to next means C2 will be on 3. Okay, it will be on 3. Now we will keep doing it until we reached to the last node. Okay, we reached to the last node. Okay, how we know we reached to the last node? If the next pointer of C2 will be null, that means we are have reached on the last node. Otherwise, another method we can another way we can do a condition check if C2 equals last node. If both the addresses of last node and last node pointer and C2 is same, it shows that we reached at the last node. Okay, now we have reached C1 is on second node and C2 is on third node. Now we will increment it again. Now C1 will be on the third node and C2 will be on C2 is here, C2 to next means it will be on fifth node. Okay, it will be on fifth node. Now we will repeat this process again. Now C1 will be on the fourth node and C2 will be on the 6 to next means 6 to next is null. That gives that our list has no other elements. It is the last node. Okay, previously it was on 5 to next is 6 and 6 to next is null. That is I can say next is equal to null. Okay, and C1 is on fourth node, that is our mid node. This is how we reach at mid node. Okay, now we reach at mid node, and in case of even numbers. And what if we have, let me show you for odd numbers also. Here number of nodes are odd. Now both are on 1. Now it will increment it by 1. 1 will be on second node and now it will move on 1 to next means on third node, and C1 will be on third node and C2 will be on C2 is here, C2 to next means it will be on fifth node. Now we have reached at the last node. C2 has reached at the last node. Now C1 is on the mid position. Okay, this is how we repeat this both these statements and we get mid element. Okay, and what is the complexity of this approach? Complexity of this approach, we are doing this process by only n by 2th time. Complexity will be big O of n by 2. If we simplify it, it will be big O of n. You can say, but it is better approach. Okay. It is a better approach. That's why I told you in the starting, it is a smart approach. Okay. In comparison to divide the total number of elements and move from one to last. Okay, for getting the number of elements, if you are not given number of elements of a list, you have to find the total number of elements, and for doing this you have to traverse all whole list. It will cost big of n. It is n step operation. After that you will find the mid node, and the complexity in that approach will be n plus n by 2. Okay, that will also, if we simplify, that will also be of an operation, but it is a, I personally feel it is a better approach. Okay, let me first write the code. If first node equal null means if we don't have any element in our list, we will simply return 0. Okay, if first node equal last node means our list has only one element, then it will return first node to data. It will return first node, data of first node. Okay, now we will take two variables of a structure type. Current node 1, that will be equal first node, and we will take another pointer current node 1 equal current node 1 to next, and current node 2 equal current node 2 to sorry, yeah. And what we have to repeat these two statements and by 2 times. What will be the condition for come out from the loop, that is current node. If current node equals should not be equals to null, a loop will work if current node is not equal to null, and current node 2 to next should not equals to null. Okay, why I am writing the second condition for even number of nodes, and first is for odd number of nodes. Okay, now we will return with the data of the mid node. Mid node will be on current node 1. Okay, now I'm just calling this function by printf. Okay, now I'm just pushing back an element. I'm increasing the size of data structure. Means if previously we have 5 elements, I have traversed it and printed the, sorry, this is not size, and just printing get mid. Okay, after that I pushed back and added an element. Now sizes sizes of the elements, size of the nodes is even. Previously it was 5, that is odd. After that I have traversed it, and again I will take let me call it, let me run it. Here previously we have 5 elements, that is odd, and mid element is 12, that is the third node. Okay, now I have pushed back another element. Now we have a number of nodes 6. We have 6 nodes, and now fourth node is the mid node. This is fourth node have the element 13. This is how we find the mid node. Hope you understand how we find the mid node. And I want to tell you, you should practice different types of question, different types of operations of linked list, like delete operation, traverse operation, delete from the last, delete at a specific point, delete at I recommend you to do it on your own, that delete the mid element and delete the element at the given position, and delete the given node. Okay, if you have to given the node, suppose, let me tell you, this is our list. If I tell you that delete the 30th, delete the element, delete the node that has element 13, means you have given only 13, and you have to find where is 13. In this operation you have to implement search operation. You have to do linear search. This is big O of big N step operation, n step operation, and you have to move from first node to the second last node, and if you find that node, you must delete it. Okay, do this on your own and see what happens. Okay, now hope you understand the concept. If you understand, Please like my video, share with your friends, and subscribe my channel. Okay, thank you guys. Thanks for watching. Happy